Hey, so a few months ago I made a video where I showcased a Mario Kart Wii remake that I made, and I was planning on doing some behind the scenes video, but that never really happened. I started working on it, then I got bored, but recently some people seemed to be interested in how I did this, so I decided to give it another shot. I tried to dig up the files that I had before, but they all got corrupted, so I kind of just gathered what I could find and I threw them into a slide deck. So that will be the first part of the video, and then the second part will be kind of a more technical overview. So this is the high level overview basically. So how was I able to get this remake to look so accurate to the original game? So let's see, if you want to do this, how would you approach this? So there's a few options. One is you remake the entire game from scratch, but then yeah, it's a lot of work and you're never gonna get it to look completely right. It's always gonna be a bit off, I think. So this is not an option. The second option is to actually decompile the entire game, which is what Super Mario 64 did. There is some effort going on the Mario Kart Wii side in remaking the physics engine, and they've been able to do some pretty impressive stuff actually, but it's not there yet in the way that I wanted to use it. Do definitely check out this project, super cool. But that's not what we're gonna do. We're actually going to, well, I guess there's 3 options instead of 2, but we're gonna spy on the game. So we're actually gonna cheat a bit. We're not gonna fully recreate it. We're gonna let the game do most of the heavy lifting. So how will we do this? So the main idea is this. You have the game running in an emulator, so in Dolphin. Then we make a program that can read from Dolphin's memory. So in this case, I wrote it in C++, but it doesn't really matter. And then we use this program to then send the data to a game engine, which in my case is Godot, but it might as well be Unreal or Unity or whatever. So let's maybe look at a concrete example. So let's say these are the memory values. Let's say we want to display the amount of mushrooms that we have in the game engine. So what we will do is the program will basically every single frame read out from memory and send it back to the game engine. So in this case for the mushrooms you can see that there's a memory address with the value 3, so that's probably the amount of mushrooms that we have. So it reads it, then sends it back to the game engine, and it knows now, okay, I have to display 3 mushrooms. And if at some point this changes to a 2, it will be sent again because yeah, it's reading every single frame. And so now instead of 3 shrooms, we will display 2. That's basically the idea. For mushrooms, of course, this is very easy because it's just a single value that you have to read. But if you want to display the entire game, what are the things that you would need? Let's start with the camera. So for the camera, what do we need? We need the position, the rotation, and the FOV. So if you read all of these 3 and then plug it into our game engine, this is what we get. So looks pretty good actually, although we're kind of missing the character. So the next thing is the player. That means the vehicle and the character model. So for these, we read in the position, the rotation, and the scale. Now, the vehicle is not as simple as just the vehicle. Actually, all the vehicles, they consist of several different parts. So in the case of the Bowser bike, this would be all of these parts. So that means that the tires are different and the handle, because they move independently. So for example, the tires rotate on their own, the steering wheel also turns. So if we read all of these separately, this is what we get. So if you look closely, you can see the wheels spinning and you can see the handle rotating as well, or turning, I guess. And then what we need to do is just add Funky Kong on top. And then it looks like this. I think he's looking a bit stiff, so I think we have to liven him up a little bit. So for the animations, we just need to know which animation is being played currently, but also where in the animation we are. Because for example, the drifting animation, that's one animation, but depending on how hard you're tilting the stick, you're in a different part of the animation. And if you do this, it looks pretty good. So this is basically it. Except that he's now kind of driving around in the void, so let's maybe decorate his environment a bit. So that means actually making the track. I basically just remade the track in Blender. That's what I did. I kind of added some new elements to make it look a bit more new, but it's pretty straightforward. Except that this was actually not simple at all. I took, well, I don't know, it took maybe 3 days or something to just place all the blocks around the course because nothing lined up. And it took me a while to figure out why this is the case. And then I figured out that if you look very close at the textures in game, you can see that the blocks are not all the same size. So I hope I didn't ruin this track for you. But if you look closely, you can see that the first block, for example, is smaller than the other 3. And this happens throughout the entire course. So I think that the developers kind of stretched and squished the textures to kind of make everything fit. And I think next time I'll pick a different track to remake. That's pretty much it. So this looks very easy. I'm skipping over a lot of details though. In total, this took about 2 months of work. I don't think I ever want to do it again. It was very interesting, but that's it. So maybe, I guess now we can go into a more technical overview for those who are interested. So at the heart of the project, we have this program, which, to explain it as simple as I can, it spawns 2 threads. So one is the game loop, and the second is a server. The server is basically to allow us to communicate from within Godot to the program. And the game loop, what we do there is we basically run a Lua script every single frame in the game. So the reason why I used Lua is because it just made it a lot easier to prototype and figure out stuff as I went along. So the Lua script itself looks like this. Basically, every single frame, we just read a bunch of data. So it's kind of what I explained before in the slides as well. So for example, we read in the camera data, the item data, the player, like the player position, all of that. Let's maybe take a look at some of these. So for example, here we get the position and rotation of whatever, I guess the model in this case. Here we read in the animation that is currently playing, how hard we are steering, whether the bike is an inside drifting bike or not. Let's take a look. What is this? This is the camera rotation here. This is the camera FOV. The speed of the vehicle. I'm not sure why this is actually relevant. I don't remember. But the mini turbo, for example, the mini turbo charge, which we use to display the particles. This is the minutes, seconds, and milliseconds, which we use for the timer, whether the game is finished or not. The item that we are currently using, the item count. So basically, this is just run every single frame. So how do we run this? We basically just call the program. Here it's just called out. And then we pass in the scripts, which I just showed you. So this will then, okay, here we go. So it's printing every single frame. So you see how many times this is reading. And then in Godot, I made something to make my life a bit easier, which is basically to show all the data that is being read. So here, right now we're not in game, so we're not going to see anything.
So you see, for example, the item is 0, ID 0, but let's maybe go inside of Super Mario Circuit, SNES Mario Circuit 3. And then once we're in game, you'll see here we have the FOV, which is set to 55. Let's maybe play around a bit and see the values change. So the moment we shroom, the FOV will actually go up. So you see now it went to 66. And also, this is the item we have, which is the mushroom. Now we have 2 instead of 3. What else can we see here? So we see, for example, these are all the card parts, the body, the handle. And then for all of these, we have the position and rotation. Let's see. So you see if I move around, these values change. So this was just to make my life a bit easier while working on this. But of course, that's not the interesting part. The interesting part is the actual thing. I don't know what to call it, actually. It's a thing. That's what it is. Alright. So, it's kind of big. Let's maybe shrink it a little bit. So you can see that I'm just playing at the same time. So since everything is being read live, I can basically just look at the left screen. Also for some reason, drifting to the right looks... Something is wrong with the animation. I don't know what. Let's just pretend it all looks fine. But yeah, you'll see that it basically does everything that we're doing in the right screen, which is pretty cool. Also, for example, let's see. If you look at the light, is dynamic, right? So you see that when I'm charging my mini turbo, the surrounding actually lights up, which I think is really cool. Let's stop this and let's take a look at the project maybe a bit more. So here you'll see this is just a track basically. And also something I did is... Oh, why is it so hard to move? Yeah, get over here. Yes, so basically the boost panel, I also put a light here. So there's a yellow light. You can see it's super subtle. It goes very quickly. If you see it, like there's a split second that there's a yellow light. Just a small detail that I kind of like. But yeah, so that's the track. This is the dummy track that I used in the slides. Here's Funky Kong. You can see some animations here. So there's a lot of manual work though. I had to put all of these in here. It would be kind of cool if you can also just export all the models from the game itself live as well. But I didn't get to that. This is the UI. This is the mini turbo. So this also I had to recreate. This is the only particle that I actually recreated because it's actually kind of a lot of work and I think it still looks bad, to be honest. The fun thing is we can kind of mess around with this. So let's say we want to... let's just increase the size of this thing. Like this. So now in game, when we now use our mini turbo, it will look super dramatic. Look at this. That's nice. And then maybe the last thing I want to show is these things. So the pipes and the oil. So this is actually not part of the track. Because they are stored separately. So what I had to do for this is I actually wrote another script to read out all the data. So actually I also get the item box data. So I get the location of all the item boxes, which I don't really use in this case, all the pipes and all the oil puddles. I dump all of them into a JSON file, which I then read in Godot to place them correctly on the track. So if you'll see in here, there are no pipes on the entire track because they are loaded dynamically based on this JSON file. So for example, here you see this is one of the pipes. It has a position, rotation, and scale, and then I just read all of these in and place them dynamically. So I guess, so technically I could also put the item boxes here, which I didn't do. I think that's it pretty much.
So I found some clips from when I was working on this, and I think it's kind of interesting to go through them just to see like where it started and how it progressed. So in this video here you can see I basically just replaced Mario with a sphere, and it kind of looks okay. So you can see that he's kind of, let's see. So you see that it's kind of jittery, but it's kind of following the movements. Let's see, I don't know what this video is. More of the same thing, I think. Although, here, here the camera is kind of messed up. What's this one? This one looks pretty good. This one looks quite good. So you can see it going up and down. What's this one? This is where I loaded Mario Circuit 3 already, except that it doesn't have any textures. This one, a very shiny ball. This looks kind of, it looks kind of funny. Let's see. Yes. So here, what I try to do is, a sphere is kind of easy, but it doesn't really show the rotations. And here you can see that I was having a lot of trouble getting all the transformations to be correct. So you'd always have this weird cube that kind of warps and does some really weird stuff. That looks kind of funny. That's me hitting the oil puddle. And then at some point I got it right. And here you can see top-down view where you see that the vehicle is kind of moving correctly, except that the front wheel is kind of in the wrong place. And same here. So you can see that the wheel is in the wrong place. And here I got it working, I think. Yep, that's it. All right, I hope this was somewhat interesting. And I don't know what else to say. Goodbye.